Hello there guys, Teacher Krishna here and welcome to our next class for the third unit. This is a class that is part of Behave School and 10th High School. Of course, we're going to be working on the subject Physics 1 and week number 24. So let's go over our presentation for today. Remember to have your notebook with you in order to make today's summary. Of course, keep in mind to add these parts to your summary: date, ending mind, title, summary, and some extra decoration to it. Today we're going to be working on topic 3.03, Newton's third law. And the ending mind for today is the following. The students will be able to understand and describe Newton's third law by completing several theoretical and physics problems. Alright, and just like every week, let me give you a small summary of the activities that you need to complete today. First, of course, watch this video and make your summary. Read topic 3.03 and complement your summary. Just like always, I include most of the content in the presentation, but it is always good for you to go over all the topics so you can complement a little bit more your summary. Then, complete practice 3, 4, and 5. You will find those exercises in page number 2. I will give you some application exercises in this presentation, but it is always necessary that you do a couple by yourselves. Alright, and take the assessment for topic 3.03. Remember that it is always important to review a little bit of the topic before taking the assessment. Alright, so let's go over our topic for today, Newton's third law. So the Newton's third law is something very simple. So basically we have an action and we have a reaction. Let's analyze the picture that we have right here. So we have an action. So air rushes down. So if this one is the action, what is the reaction? Then the balloon goes up. There is something else that we need to analyze with the Newton's third law. Which is basically that whenever one force is being applied to a medium or to an object, another force that is exactly the same as the other one, but that is acting in the opposite direction, is acting over the same medium or the same object. So probably right now it might sound a little bit confusing, but we are going to analyze a couple of examples later on. So basically for every action, there is an equal and opposite reaction. Those will be in way simpler words, all right? So I think we are going to understand this law by analyzing some application problems. So here we have the first one. So it says, consider hitting a baseball with a bat. Which scenario is true? We have letter A, the baseball exerts a greater force on the bat than the bat exerts on the ball. Letter B, the bat exerts a greater force on the baseball than the baseball exerts on the bat. Or letter C, the force that the baseball exerts on the bat and the force that the bat exerts on the baseball are the same magnitude. Alright, so here is a little bit tricky because as most of students will say that the correct answer will be letter B, because they are considering that the mass in the bat is actually bigger than the one in the baseball, and just comparing sizes we will right away say that the bat will actually apply a greater force to the ball. But in reality, the correct answer will be letter C. So the force that the bat is applying to the ball and the force that the ball is applying to the bat are exactly the same, because it will follow the principle of the third Newton's law. All right, so let's go over more examples. We have this one, practice number 4. A large truck and a small car have a head-on collision. So which scenario is true? So letter A, B, or C. So just to go a little bit quicker on these options, I'm going to tell you that the correct answer is letter C. So the force that the truck exerts on the car and the force that the car exerts on the truck are the same magnitude. So when both vehicles collide, they are going to apply the same force to each other, right? Because remember, whenever a force or an action is applied, equally an opposite force is applied to the same object. Let's go with one last example. So Ryan is driving his car to band practice. His speed is 55 miles per hour. Splat. A bug smashes against the windshield and bug guts are everywhere. Gross, right? So which scenario is true? And one more time, let's go a little bit quicker over the options, and I'm going to tell you that the correct answer will be letter C. The force that the windshield exerts on the bug and the force that the bug exerts on the windshield are the same magnitude. So here's the thing, how is that possible? If, of course, we have a very large car and we have a very tiny insect, how is it possible that they actually receive the same force? And probably it might not seem very obvious to us, right? So let's continue with some extra explanation. And I would like to go over this principle by analyzing one of the examples that were shown in Agilix. So we had an example of a leaf that is coming down from a tree. So when the tree falls to the ground and it touches the ground, it is acting towards a very gigantic mass that will be our planet. So the force that the leaf is applying to the planet is exactly the same as our planet is going to apply to the leaf. But one more time, it seems crazy, right? How is it possible that the same force is being applied? And if that's the case, how is it possible that the leaf actually touches the ground and stays there? So what happens is that in the forces that are being applied to both objects, in this case the leaf and also our planet, are acting upon different masses. So, of course, remember the Newton's second law. If mass, then we're going to have a lower acceleration. And we have a lower mass, we're going to have a higher acceleration. So, when the leaf actually comes to the ground and it touches the planet, it is applying a force to our planet. But of course, the force that the leaf has applied to the planet is extremely small, that it is not going to move it at all. And the planet is acting exactly the same force that the leaf has applied to it. But of course, it will be a force that will go up. And since the force is exactly the same, then that is why the leaf is going to stop moving, because at the end, the forces that are going to apply upon the leaf are going to be balanced. All right. So one more time, we don't have a higher or we don't have a lower force that is being applied on objects. They are exactly the same. And that's the reason why they stop. So when an object touches another object, two forces in different directions are applied over them. Remember that the objects have different masses, so their behavior will be different. A higher mass requires a higher unbalanced force to change its motion. Yeah, pretty much this content is related to the example that I was giving you before. So let's continue and let's go over more application problems. All right, we have this one right here. In the example below, the action-reaction pair is shown by the arrows, or since we call them in physics, it will be vectors. And the action-reaction is described in the words. In A through G, draw the other arrow or vector and state the reaction to the given action. All right, so I mean, this looks like a tongue twister, but it is way simpler than it actually looks like. So the first one says, fist hits wall. Right, we have a person that is hitting the wall, and the vector is showing us that it is going towards the right. So remember, an equal force that is going to go on an opposite direction is going to act on the fist. So just like you can see right here, we're going to draw our vector with another arrow. And we are going to complete the statement by saying that the wall hits fist. All right, so let's continue. In this one, it says head bumps ball. So if we just turn it around, it will be ball bumps head, because a force that is coming from the ball is going to hit the person's head as well. So remember to signalize it with an arrow that is coming right here, in the exact opposite direction. Let's continue. We have another one right here. So we have the windshield hits the bug. So one more time, what's going to happen if we turn it around? So bug hits windshield. So remember to draw the arrow that's here that is going to signalize the vector right there, or the micro tiny force that is going to be applied to the car as well. And the next one, it says a bat hits ball. So the ball hits bat, because one more time, when both objects touch each other, they are going to apply two forces, but on a different direction or on opposite directions. So remember to signalize the vector right here that is going to come towards the opposite direction that is being shown in the picture. Oh, all right, so basically those will be the application problems, and that'll be the class for today. So you still have to complete a couple of exercises. So probably you might be thinking that we are not using a lot of formulas right now, but it is very important to remember that all the Newton's laws are going to describe the behavior of objects. So they are going to describe the way they are going to act when several forces are being are going to act upon several objects. But don't worry, later on we're going to be using way more formulas, and of course we're going to be doing some more physics problems that relate to them. And that'll be it. If you still have some problems when understanding this law, you can always contact me in WhatsApp. I will be more than glad to help you out right there. That's it then. I will see you during the mid-session that we have in a couple of minutes. So goodbye, everyone. I will see you around.